Think I'm live. Yes, I am. Hi guys. How are you guys doing? This is Jero Serrano, and I developed a 3D game engine called Untitled Engine. And thank you for all of you that are joining my channel today on this Sunday. And basically today, what I wanted to do, I want to share with you what I have been learning throughout the week related to regarding artificial intelligence in games. Um, I've been wanting to do that for a long time actually, and I think now the engine that I've been developing is ready for me to implement an artificial intelligence system. And before I start doing that, I need to really get a good handle on artificial intelligence and how it works. So before I begin, how are you guys doing? Um, I really don't have any announcements aside from what I'm going to be sharing with you today. Um, but I do want to share something with you actually. If you notice, when I started streaming back in February, I would go live, I guess, like 2 or 3 times a week. Um, in one particular occasion, I I try to do it like almost daily for a short burst. But I stopped doing that, and what I decided to do instead, and what I did this week was basically I decided to go live only once a week, and in this case only on Sundays. And the reason being is that when you go live on Twitch and you do like live coding, believe it or not, it will slow you up. It will slow down your productivity. And I noticed that it was affecting my work. So I decided like to cut back, and instead of boring you watching me code, I decided why don't I just do like a type of a summary of what I have done, and show that on Sundays. And hopefully that's more entertaining, and a better use of your time than uh, watching me code for 2 hours. And many times the problem is that I could be coding, and I may run into a bug, and I may not know how to fix it at that time. So uh, I felt that I was just wasting your time watching me. I'm watching me debug code, right? So I try to change that. All right. So basically, what I'm trying to say is that for now, what I'm going to do, I want to just go live on Sundays, and see if that is more productive and more beneficial to you and to me. So that's my plan for a while. All right. So let's see. Let me put some music on. Uh, if you've been following me on Twitter, I've been sharing some photos of what I've been doing with artificial intelligence in games. And so what I did was basically I ended up buying this book, Artificial Intelligence by Ian Millington. As of now, it's a very interesting book. All right, I'm on chapter 3 right now, and I've been learning about steering behaviors in artificial intelligence. It has been good, very informative. But I also I had this other book also for a long time now. It's called Programming Game NI by Example, by Matt Buckland. And this is also a really, really good book. And I actually ended up buying this book, like I guess like in 2016 or so, because once the engine started to work, um, I was so eager to develop a soccer game. Um, and I spent about 6 months on just developing the soccer game. And little did I know that the artificial intelligence in a soccer game is so complex. It's extremely complex that um, it was taking me a long time to figure things out. So I stopped developing the soccer game because I felt that I was also losing focus on the development of the game engine, right? The game engine at that point was not lacked a lot of features, and it felt that I was just branching off into developing a soccer game instead of improving the game engine. So I stopped, and I basically, I started refocusing on the game engine again. But now I'm back and in doing the game artificial intelligence. Actually, let me show you what I did. So you can actually see it. So if you go to my website, and if you do a search for soccer, I'm gonna just do it so you can see it. You should see actually several articles that I wrote about soccer artificial intelligence. Now I'm gonna be honest, these are not like the best articles on artificial intelligence, so just read them, but don't take too much out of it. Like it was obvious. I was learning, playing around with it, and I was just sharing it with you. There are some articles that I wrote about this, actually, about state objects. Now those are really good, and you should take a look at those articles. So basically, I'm gonna play a short video here. So I have like the players here, and they are basically passing the ball around. I tried to implement a group AI system for the whole players, and you can see them actually moving around. It works, it's decent, but it's not the proper way to do artificial intelligence, and I was aware of that. And now what I want to do, I want to implement an artificial intelligence system in the game engine, so that way when I want to implement whatever type of game, I will have that system already implemented the proper way. All right, so let's begin. All right, so this is what I've learned. Let me bring this up. So one of the things that I learned was that how the an artificial system should work. What's the whole model of it, right? So basically, an artificial system should have two type of subsystems. One which is dedicated for a group strategy, like when you have like a set of soccer players. You want all of those soccer players to follow a particular strategy that is being provided by the artificial intelligence. And then you have the other subsystem, which is basically which involves like the artificial intelligence for the character independently, such as a particular player in the game, right? So for a character AI here, you have decision making and then movement. So decision making would be, when do I pass the ball to another player, or or when do I shoot to goal, and then movement. That really is related to are you going to go for the ball? Are you going to to try to flee from a player? I don't know when you would do that in soccer, but or when are you going to, or also predicting where the ball is going to be at and try to intercept it, right? So those are the movements. And then once you have decided on what movement to apply, then you send that information to your animation and physics system. All right, and that's basically when you when you actually see the character moving, animating, moving from one location to the other, etc., etc. So that is that. So basically, this the whole artificial intelligence system that you should implement. You have to the group artificial intelligence and then the character artificial intelligence. Now here I also have an input, right? An input is from the world interface. Basically, that is when, for example, let's say you have a character that is about to collide against the wall, right? Well, the character needs to be somehow aware of its surroundings, right? It needs to be aware of if there's any obstacles ahead of him or to the side, or if there's a particular opponent, right, about to shoot him down, right? So he needs to get that input from the world, and then send that data to the to the AI system, make the decision, apply a movement, and then send that information to the animation and to the physics. All right. So what I did this whole week was basically I read from chapter 1 to 3, and basically those chapters basically they focus on the movement section of the of the AI system, and in the movement what the book focus on is basically on the various steering behaviors that you need to implement in an artificial intelligence system. So these are the steering behaviors that at a minimum you should have in a system, right? So, and I'm going to go one by one, and I'm going to show you how they work in all of that. So you have seek, where basically you have one character, seeking for the other characters and moving towards that position. Then you have flee, which means you basically one of the characters try to run away as far as possible from the other, to prevent from being caught or shut down or anything. Then you have another behavior called arrive, and arrive is basically same as this particular behavior, seek, but instead of approaching the target at maximum speed, you slow down your speed as you get closer to the character. So that's the arrive. Then pursuit is basically when you try to predict the position of the character at a particular time, right? So for example, the current position would be here, and what you try to do is like predict the behavior depending on the current velocity and the current and the time that you want to apply. So then you basically end up calculating the predicted position of this. And then the other ones where you the other steering behavior is wander, and basically here's when you have a character just wandering around the world, moving back and forth all throughout like the whole terrain or whatever. So let's go one by one, all right? One of the things that I noticed here, and I'm gonna actually make this bigger, and I'm gonna make it bold. And let's see if I can even make this way bigger than this, so you can actually see it. So this particular equation is quite useful to keep in mind, all right? Because this is what you want. In every of these steering behaviors, what you want is a final velocity. And the final velocity will basically be applied to your physics engine, right? And that will make the whole motion, will apply the motion to the character. So this equation basically states that you want a desired velocity and minus your current velocity. And I've been reading, from the books that I've been reading and from websites that I've been visiting, it seems that if this is a very important thing to keep in mind whenever you are applying steering behaviors. Final velocity, desired velocity, minus current velocity. All right, so let's go with SIG first. And SIG basically, what it does, this is my character. These two characters right here. This one is the one that is moving around, and this one is the one that is trying to catch this character, right? So basically how it works is like this. My current velocity for this character is going that way, right? Now, and I want to get to this character right here, right? So what I need to do is I need to compute my desired velocity. So which means I need to somehow compute the direction, right? So my desired velocity will be from this guy to this guy, right? So basically, you get the position of this character minus the position of this character, and that will give you a direction. All right. So so now you know your current velocity, and now you have computed your desired velocity. All right. And now what you do is you do like simple vector arithmetic, right? So you have your current velocity minus and this guy. So for you to get to this guy, so it means that you need to subtract desired velocity minus your current velocity, and that will give you this particular vector right here. So let me move this here. So my desired velocity minus my current will give me this vector. And if you're a little confused, you know, you can just do this. I'm gonna actually just flip this. Boop, boop, boop. Right. So some people are used to when they are dealing with vector arithmetic, which I don't even know if that's actually a proper term, arithmetic for vectors. But you know what I mean, addition of vectors and subtraction and everything. So you know, you go desired velocity plus the opposite of the current velocity, which will be this one, and that will give you this particular vector, which is this, right? So in case you have problems understanding how that works. So once you have applied this, so your final velocity will be this vector right here. So which means that the car will start moving this way, will start focusing to go on that particular location. Now again, the whole arithmetic, the mathematics involved is quite simple. I'm going to bring up the code here, and I'm going to bring up the section of the code that I did sig here, right here. So basically, the first thing that I do is I get the desired velocity, right? And I get the desired velocity by simply subtracting my target position minus the character absolute position. So basically, the target position minus my character position, and that gives me this direction. All right. That's the thing you need to keep in mind. We want to know that direction, all right, the direction of that vector. So once you have that, I'm going to normalize it because what I want is the direction. Then I'm going to set the speed, and in this case, I'm going to multiply the velocity by 3. That's my speed that I have giving it to. And once I have that, I just compute my final velocity. And all what I do is I subtract the desired velocity, which is what I calculated here, minus my the current velocity of my character, which is current velocity, this one, right? So desired velocity minus my current velocity. And after that, I return the final velocity, and I give the final velocity to my physics engine, basically. And that will apply the movement. So I'm going to run this so you can actually see it. Turning on my controller. All right, so I'm going to build this right now. And it is building, so I'm gonna go to my Mac. All right, so the astronaut with the white suit, that's the one that I'm controlling, and the astronaut with the gray suit, that's the character that's going to be basically trying to catch my character. All right, so that's the one that's doing the whole seeking algorithm. All right, so I'm gonna move, and I'm gonna start seeking to it. So now if you see, if I move around, the character will want to catch me. You see that? And that's it. So let me stop that and come back to that. So basically, as you can see, that's how simple it is to implement a seek algorithm. A steering behavior based for the seek is quite simple. If you keep this in mind, that desired velocity minus current velocity. Now the other one that you can implement is the flee, and basically flee basically is the opposite of to seek, right? Instead of the character approaching the character, now the character is going to try to run away from the character, right? And again, this equation pops up again. Final velocity is equals to desired velocity minus my current velocity. Now the only difference is that this vector, my desired velocity, is actually flipped, right? Instead of computing it from my target position to my absolute position, I compute it now from my absolute position minus my target position, right? And then I get my current velocity, which is for my object itself, and that will produce a vector that is going to send it all the way back to the other stuff. So again, you know what, let me actually do this in case you are wondering how the heck do you ended up getting that vector. Let me see if I can explain this. So basically, if I move this vector over, I'm gonna need to copy it over here, right? That's the desired velocity. And then let me copy this and let me flip this, and I put it here. Come on. So that will basically give him this velocity, right? So desired velocity, which is this guy, plus the opposite of this vector, which would be this one, is going to give me this vector right here. So that's how you can compute it. All right, so how do you implement that in code? Well, it's not the same as seek, but the only thing that this particular vector is flipped, right? The desired velocity is going to be get absolute position minus my target position, and in comparison, seek is the opposite, right? And again, after that, I basically normalized my velocity because I just want that I want the direction of the velocity. Then I multiply by a speed, by a scalar of 2. That will represent my speed. And after that, I just compute my final velocity, which is again desired velocity minus my current velocity, and that is that final velocity is given to my to the physics engine, and it produces the whole movement. All right, so let's see how that works. So I'm gonna run this again, and if I'm not mistaken, it's right. Okay, so let me go to my Mac, and now before I begin, I'm actually gonna put my character right behind the character that's gonna be doing the whole. It's gonna be fleeing from. So remember, the astronaut, the character with the white suit, is the one that I'm controlling with my controller with my gamepad, and the character with the gray suit is the one is doing the whole steering behaviors. In this case, it's doing the whole fleeing away from my character, right? So I'm gonna press flee, and you will see how it starts fleeing away from this. And there you go. All right. So let me go back to here. All right. So that's flee, right? Now the other one that is one of the basic steering behaviors is the arrive. All right. And in the book, how they illustrate the whole arriving algorithm, they do it differently. But I felt that if I illustrate it like this, it's gonna make more sense. So basically, this algorithm is exactly like seek, right? But instead of having an absolute speed, um, you will manipulate that speed depending how close you are to your target. All right. And why do you do that? Well, because if you once the character, if you don't apply, if you don't have this, if you don't manipulate the speed, um, once the character reaches the target, it's just going to be oscillating back and forth, back and forth, back and forth. And I'm going to show you what I mean by that. But basically, the whole algorithm, how it works, is that depending how far you are from your target, you change the speed, right? So during every game take, I just basically compute how far am I from my target, right? If I'm between this radius right here, up beyond this radius, I'm gonna set my speed to 1. Once I get closer to this radius, then I set it to 0.4, and if I go to even closer, then I reduce the speed even further. So at every time, the whole character will start slowing down as it gets closer to the character. Again, it's the same as Seek, but just with the additional computation to compute my distance, which is this guy. If my distance is greater than 0, then I just basically compute the speed. I obviously, I do not want the speed to be beyond a particular parameter, so I set a maximum speed and then do a min, just in case I don't overshoot that speed. And once I have that speed, right, I apply it to my desired velocity. And again, instead of doing it here like I have it here in SIG, right, which I just apply a scalar of 3, here I'm just applying the particular parameter that corresponds to that distance, and then I give it to my final velocity, and I give that to the physics engine, and you do the whole motion starts. So let's see, let me run this. So right now it's building. I'm gonna go to my Mac. Alright, so you could see this. I'm gonna go over here. Alright, so I'm gonna ask the characters to do an arriving algorithm. And you see how it starts out fast, but then as it gets closer, it slows down. Watch. You see how it slows down as it gets closer and closer. And the farther it is from the character, it goes full speed, but then it slows down a little bit by that. Now let's say that you don't have the particular arriving, and I just do a SIG. You see what happens if you don't have that implemented. You see that? So that's why you need to implement kind of an arriving algorithm, so you don't get that. I'm gonna do that. So if I play the arriving again, you will see something like that, slowly reaching the character. Alright, so that is that. Then the other steering behavior is basically the pursuit. And this one, basically what you do is again identical to this particular algorithm, SIG, but in this case what you do is, instead of you trying to get to this position right here, you predict where the character is going to be at a particular time. So initially you have this character right here, which is the guy doing the whole trying to catch the character, and this is my character in my current position. Right now this character has a particular velocity, it has a current position, right? But you also know that you can compute the predicted position once you know the velocity and you provide a time frame, right? So at a particular time, the current position of this character will be somewhere around here. So instead of you setting your desired velocity to point to this guy on this in this direction, you set the desired velocity to point in this direction. So that way you can catch that character, right? Intercept the character basically. So the pursuit is basically the same thing. You get the desired velocity. You set a particular speed. Now here's where you set a particular time, right? And the time is up to you, however you want it. In this case, what I've done, I basically computed this distance. I got this distance, and I scale it by my speed of my target. And then once you have that, you basically, apply this particular function. Predict the position. It's going to be the current position plus velocity times the time. And then what you do is you provide this target position. You provide it to the method seek, and it will, again, instead of looking to this guy, it's going to look over here, and it's going to apply the same logic here. All right, so let's see how that works. But before I do that, let me actually comment this out, because I was actually running another algorithm. All right, so let's do that, and let me run this. And I really hope that this new way of me going on Twitch and just giving you a summary is actually more beneficial, more helpful than you actually watching me code. I really do not want to bore you, so it's building, and it's going to come up very soon. All right, so Mac. So what I'm going to do here, I'm going to do the pursuit, and now the character is basically going to do the whole thing, but now it's actually trying to predict my future behavior, my future position. And you can actually see how it is a little bit more, it's harder to get away from my character now than when using the other steering behavior, such as sick, because now it is predicting where I'm going to be at a particular location, so I cannot just get away from it as easily as before. All right, so that's pursuit. Now the last one, and before I do that, let me put it back how it was, because I'm going to play the other algorithm in a second. All right, so the other one that I learned about is the wander, right? And this one is basically the character will be wandering around the whole scene. It's going to just move around. Actually, let me play it first so you can actually get an idea, and then I'll explain to you how it works and how you can implement it. All right. So I'm gonna go build this, and I'm gonna do the wander. Alright, so it's building, and it should be coming up in a second now. Alright, so the character that is going to be doing the whole wandering is the character with the gray suit, okay? So you can ignore the character with the white suit. So I'm going to go do the wander, and you'll see how it starts wandering around. I'm not controlling it at all. He's just moving all by himself. Let me bring him back actually. Oh no, it's coming back. Yeah, let me bring him back so you can actually see him. Let me just put it here. Okay, now I'm gonna start doing that. I'm gonna wander again. Now it's wandering, just moving around. You know, I'll come back. Basically, just exploring the whole terrain, the whole system, the whole world. Basically, that's what it does, right? So how do you implement this whole behavior? So I'm gonna stop this. I'm gonna go back to my code here. So basically, how it works is that this is your character, right? And what you do is that you create some type of you know, how can I say this? Basically, you want the character to be always seeking this particular location, this target location. All right, and this target location is at a particular has an offset from your character, and it can only move within this particular circle. All right, so what you do is that during every game tick, you compute like a random value that will move this target up and down, right? So in particular game tick, it moves up, so now your character has to start looking that way. Now the second one is might go over here, for example, and then your character changes the view, the target, yeah, the view direction basically, right? And then this circle moves over here, right? So now you are forcing your character to seek in that particular direction right there, and on and on. Then it can go over here, and then the whole seek algorithm will now look into this one. Now keep this in mind. This algorithm depends, not depends, but once it has computed this target position, it sends that information to the seek algorithm, and this guy will try to get to that location, right? But in the next game tick, this location will change. So now it changes the whole target, the whole seek algorithm, the whole view direction, and that information is sent to this algorithm seek, and then it is sent to the physics engine. So you can see how this guy, you know, eventually this guy can go all around the whole circle, and this guy will be moving, you know, all throughout, like wandering through the whole game world basically. So here's the wander. Basically, one of the things that you need to do is you need to get you need to get a random number, so that way the whole the target circle here changes position during every game tick. Obviously, you also need to create, compute this circle here, and provide an offset and provide a radius and do the whole mathematical stuff. It's not hard at all, but basically the whole gist of it is that this particular target would change throughout every game tick, and that will force this character to change views, to change direction through every game tick, and thus making him, giving the illusion that he's wandering around. That's how it basically works. All right, guys. So that's all what I have basically done this whole week. I've been reading a lot. I do want to share with you a particular website that I thought was really good, and if you're interested in learning more about steering behaviors and autonomous agents, go check out this website. It's called Nature of Code, and if you go there to natureofcode.com and go to chapter 6, the guy at Daniel Schiffman gives a really good overview of how the whole autonomous agents work and the different steering behaviors and the forces. It's actually quite good, and I really liked it. So I recommend you to do that. So what I'm going to be doing next time? Well, what I'm going to be doing next time is basically I want to start learning more about following a path, and basically I'm going to show you how this guy does it here, actually, because that's my next goal, is to learn path following. There you go. Basically where you actually provide a path for the characters to follow, and then the character needs to make sure that it follows that path as close as possible. So I'm going to be reading more about this and how to implement it. Here's a good example. You can see how the characters here are actually following this path, and how they keep close. If they get away from the path, they somehow are able to come back to it. So I'm going to be learning more about that. The other thing that I'm going to be doing is that you probably didn't notice, but all of this, you didn't notice, I'm sorry. Behaviors, I basically implemented them in functions, in methods. But I have noticed that this particular book implements them in their own particular classes. So what I'm going to start doing, I'm going to start building the whole AI system, and the first things that I'm going to do is implement the steering behaviors classes. Seek, flee, pursue, arrive, wander. And it seems that these are the most basics, and it seems that from these particular behaviors, that's you can build more steering behaviors from it. So that's about it, guys. Again, I'll see you guys next Sunday, and thank you for joining my channel today. I know it was short, but I hope it was but I know it was not a waste of your time. Alright, guys, so see you next Sunday. I will be posting some stuff on Twitter, so if you want, follow me on Twitter, Harold M. Serrano, or you can also follow my channel here, or you can also visit my website at haroldserrano.com. Aside from that, thank you guys, and I'll see you next Sunday.